Awesome. Thank you, Aryan. So our next presenters are Richard Steenbergen from nLayer Communications and Avi Freedman, who you probably know from lots of things, but is now, oh no, I've totally spaced it. Your current affiliation? Server Central, yes. I didn't want to say NetAccess because obviously that would date me to some era. Thank you. No, thank you very much. Excellent.
Hello. So we actually timed this presentation to come right after the AM6 presentation. When we saw what they were proposing, we thought this is a perfect opportunity to kind of talk about what else you could do with an MPLS platform. So hopefully this will be interesting. I'm going to start off by kind of a quick recap of the kind of the history of exchange points. So kind of the zero-gen platform was, people that got together for the first time to bypass ANS, and as soon as you had multiple parties that wanted to interconnect with each other, you had May East, which became originally an Ethernet FIDI eventually for high-speed access when high-speed was 100 megs. It had a lot of problems. It had a lot of head-of-line blocking issues. It had a lot of scaling issues, but it kind of worked most of the time. It passed most of the packets, and for when 100 megs was fine, it wasn't that big a problem. The second generation of exchange points was ATM. You had everything from ads to pack belknap. Eventually the maze went to ATM, and you had OC3 and OC12 speeds, and you had this program called PeerMaker that built all your interconnections on the maze. And then the third generation was the Gigi exchange ports. This is when basically ATM died, thankfully, which people deployed a new generation of switches, which were mostly non-blocking. You had PAX, you had the rise of Equinix, you had Lynx and AM6 taking off. You had kind of a solid platform for the first time, where there weren't really that many issues, and Gigi was fast and fine. And then eventually, 10 Gigi became the thing, and you saw a lot of transition from the existing gig exchange ports to the 10 gig, and a lot of them deployed new platforms in the process. But the exchange points themselves stayed the same. So there's been, since Gigi, there's been pretty much no one's massively swapped out their exchange points for an entirely new one. Kind of a quick overview of how all the modern exchange points work. Today they're almost exclusively Ethernet based, as we've seen. This is really driven by the commodity price of Ethernet. Thankfully ATM died a horrible death at OC12. We're all very happy. And the exchanges really became Gigi, and then as we saw in the previous slides, 10 Gigi and N by 10 Gigi has been the primary growth for quite a while now, and will be until we have faster options. Right now they operate almost exclusively as flat layer 2 VLANs, and what this means is the IX, everything is interconnected at layer 2. There'll be an IP block, usually at 24, sometimes it'll be at 23, sometimes it'll be at 25, but somewhere in that range. And every member will be assigned an IP address. And every member will be expected to nail this IP address to one router with one MAC address. They'll be able to talk to any other member because it's a flat layer 2 exchange. There'll be some broadcast traffic, typically ARP. But this is pretty well policed. If an exchange is well run, they're monitoring this. They're keeping tabs on it. When people configure protocols that aren't intended to run over the exchange or things that could be bad, they keep tabs on this, and they'll send these guys an email, or if it comes down to it, they'll shut off the port. So the exchanges mostly work. And here's just kind of an example of a large topology. And you see right now that a big exchange point is 8 by 10 gig trunks, or in the case of AM6, 16 by or whatever. We're getting really big chunks here between all these locations. So what's wrong with these? I mean, it seems to work. Well, here's the problem. Layer 2 networks are relatively easy to disrupt. You can create forwarding loops very easily because there's no TTL, there's no method to expire the packet. And it's really easy to cause a broadcast storm, have all that traffic flooded out to members, and if you create a broadcast loop, well, there you go. There's your perfect combination of failure. And this not only can take down the exchange, but it can actually take down the member router that's connected to it. It can very easily overwhelm the control plane. I've seen this happen on many platforms. And you know, sometimes there are rate limiting options and sometimes there aren't, but you really have to be careful about where you connect to make sure that you're connecting to a quality run exchange, or you're putting your entire router at risk and potentially other customers. Today we work around these issues by having hard-coded MAC addresses or MAC learning that only works to one MAC address. And basically the strict requirement is that if a peer is going to connect, it's going to have a router with one MAC address, one IP, and that's pretty much it. And like I said, they're going to monitor the exchange ports. They're going to make sure that things aren't going bad. And a well-run exchange is going to have well-trained staff that know how to solve a problem if it happens. And there's examples of poorly run exchanges that have had loops that have persisted for 48 hours. So it happens. The other big problem with the whole architecture is the accountability. The reality is most routers have poor or no mechanisms for measuring traffic over a layer 2 exchange point. The options that are available today, you've got NetFlow from your router as a member. The problem is it doesn't provide MAC layer information. So you don't know, you can't measure inbound traffic. The best you can possibly do is measure outbound traffic by next hop. And there's a lot of platforms that can't run any NetFlow at all. Cisco Catalyst 6500, 7600, very popular platform, very reasonably priced. It has extreme NetFlow limitations. And if you try to pass any amount of traffic, you're going to start dropping flows very quickly. So it's a big problem. The other options are S-Flow, either from the member router or the IX operator, and you've got new versions of NetFlow, which are essentially the same thing as this. But even if you do have MAC information, the reality is it's still sampled data. You're looking at one out of every whatever you configure, 8,000 packets, something like that. That's not one-to-one. You're still going to be off, and you could be off by as much as 5%. That's not really acceptable for billing purposes. You can't sell someone a service and say, plus or minus 5%. That's bad. And the reality of MAC accounting is most platforms just don't support it at all. And it's very difficult to integrate any of these systems with a provider's 95th percentile billing. Everyone has their own systems that integrate into their own customer databases that tie into their own billing systems. And typically these are based off SNMP. You've got to be able to SNMP query a counter somewhere. And all of these are pretty bad choices. So if you can't figure out how to bill someone, well, you can't really sell services over this kind of platform. So the reality is that the exchange points then become a poor choice for delivering billed services. You've got the fundamental security issue, which is that any member can communicate with any other member, whether this is desired or not. So you're vulnerable to traffic injection from other peers who are directly connected. There's situations where you're vulnerable to injection from people who aren't on the exchange. When there's a /24 and some member happens to announce it either to their customers, which is common practice, or to the exchange or to the internet at large, which is less common practice, but it happens, you can end up receiving denial of service traffic to your exchange port from anywhere in the world. It can be delivered over multiple people connected to this exchange point, whether you peer with them or not. The poor accounting options make this pretty hard to detect. There's a variety of things people have come up with, all the way from dedicated ribs, which only work on certain platforms, to BGP accounting, to running dedicated exchange port routers that only carry a partial routing table, that only carry their internal routes and customers and don't carry an external feed. But even then, if you have two peers on one router, you can still, one peer can reach your other peer through you. So this is bad for security, bad for accountability, bad for everything. And when we've caught people doing this in the past, pointing next hop, And whenever we catch them, they say, oh, I'm getting a transit feed from someone else over the exchange, and they forgot to set next hop self, and so my next hops were pointing to you. Whoops, we'll fix that. Yeah, I'm sure that's exactly what happened there. So this is just generally a bad thing for selling transit. Like I said, it's vulnerable to denial of service attacks, and just generally a layer 2 platform is vulnerable to ARP manipulation, CAM manipulation, where you can disrupt MAC learning. And this is why, another reason why people have to run this one router, one MAC address lockdown scenario, is to kind of work around these fundamental security issues. This was addressed nicely by AM6. It's difficult to scale and debug a large layer 2 network. The problem with redundancy is that it's provided by a spanning tree or some other vendor proprietary thing, which is the same thing but maybe faster. And the point is that if you want redundancy, you create a loop and then you have to block the loop. So there's large portions of layer 2 exchange point networks that are sitting idle, waiting for handling that failure. And to protect every possible failure case, you're putting a large amount of money into gear that's sitting idle. And idle gear, obviously, is wasting money and increasing the cost of the service for everybody. Spanning tree is, like I said, a very, very poor way to control that traffic flow. So if you lose a large link and you have 2 other paths that you might be able to split the traffic over, you have no control over that. You really need to be able to back up every path with kind of symmetrical network. And even the best and the largest exchange points, they're running 800 gigs, 8 locations. Try scaling that to 80 locations. Try scaling that to 8,000 members. It'd be a huge problem. And fundamentally, their customer base is self-limiting because there's only so many people in the world that have a router at this location that know how to speak BGP, that know how to peer. There's a limited customer base, and there's thousands of other networks out there in metro access networks all over the place that are buying and selling transit or buying transit from other carriers who can't really get on the exchange because they don't really know how to do any of this stuff. It's not intuitive for many people. You've got fundamental problems with manageability. You've got really poor controls over QoS. Essentially, the ports are wide open. Any member can send as much traffic as they want, and your best bet is to contact them and say, hey, can you ship that traffic? You're filling my port, or you have to make sure that you're upgrading your ports consistently. But that's a bad choice when you're selling paid services, because now you might have a paid customer who's being impacted by some settlement-free traffic, or even some traffic that you don't want, some denial of service traffic. And the other issue that we've run across is it's really difficult to manage multi-router redundancy. If you look at how most people connect to an exchange point, they have one router, and it connects to an exchange point. And if they want more capacity, they might add port channels. But it's pretty rare to see people add 2 routers. And there's a reason for that. What happens is you've got this LAN segment, you've got this /24 or whatever it might be, that if you're connecting 2 routers to this one exchange point, you've got this same 24 in multiple places. And if you're using that 24 as your protocol next hop, you've created an anycast effect. So in your network, even if BGP is up on only one side, both sides are going to balance traffic. Whichever router that traffic hits first is going to get the traffic. And the problem is anytime there's any kind of an issue where either, say you connect to a complex topology exchange point and they segment, you've got an east and a west half exchange point that aren't connected. You've got some peers up on one side, you've got some peers up on the other side. You might lose BGP, but you're still going to black hole. You don't really have the ability to detect downness on any one given peer like that. Or if there's any kind of issue where you don't lose link state, but you keep the port up, but it's not passing traffic for whatever reason, you're going to black hole traffic, even if it's a single place like this. And really the workaround for that, BFD, is not widely implemented on exchange points. Other issues with the architecture, it's really difficult to do inter-network jumbo frames. If you look at the architecture of most routers, they actually have the capability to set on a per next hop basis an MTU. And there's actually no way to negotiate this right now. So what happens if you ever want to, try to grow past 1,500 bytes and try to, expand the MTU of the internet into other networks, you find yourself trying to come up with a common denominator. What's the lowest MTU that we can get away with? And given the wide variety of boxes out there with a wide variety of MTUs and different limitations and software bugs and everything out there, it's next to impossible to come up with a common MTU. And that's why you really don't see much adoption for larger frame packets over exchange points. And I think that's hindrance to ever rolling out jumbo frames on the internet. Obviously, the service is constrained to IP only because anything else would be against the exchange points MOU. They're giving you a /32 out of their /24, and you're expected to do IP. IPv6 that has been added, but you're not really able to use this platform to do transport services. So I mean, the bottom line, the layer 2 exchange points, we managed to make them work. They're okay. They work for free peering, but there's a lot of inherent problems. It's an unstable system, and we've put a lot of time and effort into making sure that it works. But fundamentally, the architecture itself, it's a very poor choice to buy or sell services, deliver full transit, to do transport handoffs. It's not taking full advantage of the infrastructure that's there. So, Avi is going to talk about how to engineer something better.
So the most common architecture of the modern exchange point is that there's a shared broadcast domain. And that leads to a lot of the complications in terms of operational complexity to prevent excessive broadcast and security issues because all the broadcast goes to everybody. An alternative architecture is something that we actually saw in whatever gen that was, Gen 3 or so, which is ATM frame relay exchanges where you actually have point-to-point connectivity between the different members of the exchange. So sort of like a PNI, a virtual PNI implemented across the fabric. It adds some overhead in the setup process because it isn't a big multi-point that everyone can see each other, but it gives you some security, accountability, and privacy advantages. So on Ethernet, simple way to do this is with VLAN. And a lot of the shared exchange, a lot of the current largest exchanges do actually allow you to add VLANs to your port and do some element of this, although it's not the recommended way that people do peering. So with VLANs, you can actually have multiple connections that could be point or multi-point, point-to-point or multi-point, delivered to you along with the shared LAN that's the exchange point. And of course, this was how some of the older exchanges ran back when we had PeerMaker and we could knight you the king of peers. But it's not that simple. There's some reasons why people haven't taken straight VLAN technology in the layer 2 space to do tons of point-to-point. And the biggest issue is limited VLAN space. You actually start having to have people negotiate over what incompatible or compatible sets of VLANs they have, but even just from a scalability perspective, there are only so many VLANs that you can allocate, just in terms of the namespace. With traditional Ethernet switches, you'd actually need to have a VLAN ID, 40 would actually need to be broadcast all over the place. And even though some of the switches that are being run can actually do layer 3 and MPLS, straight layer 2 space, those VLAN IDs are global across the system. So scalability-wise, if you actually tried to have VLANs between every member in the exchange and have them be unique, at 65 members, you'd actually fill up the namespace and you'd have a problem. The straight layer 2 VLAN rewrite solutions, actually, we did some work looking at what one could do, and a lot of those actually wind up, you can rewrite 40 into 50, but you're still burning 40 and 50, at least on that line card or at least on that switch router. So that becomes an issue. But it now has to, the IX in a straight VLAN point-to-point implementation has to be the arbiter of who can use what VLANs. And again, most of the customers of exchanges are now not running straight routers, although that's sort of changing. But at any given exchange point, more than half of people are going to be running things that are fundamentally switches that have grown router capability, where fundamentally that VLAN ID is unique, is global across all ports, not unique to that port. And so it puts the exchange operator in this intermediary role. You have to have a complex provisioning and negotiating system. It just becomes difficult to do that management, and the negotiation would be very difficult. So what would you actually need to do if you wanted to implement, get people away from the shared broadcast, get towards a logical PNI that people could implement across the platform? Just doing VLANs is difficult. There just isn't enough namespace. You're still in layer 2. The devices that people are connecting to your exchange are going to take any VLAN ID as global. And the VLAN rewrite, the tag rewrite technology that's actually in most of the switch routers is not that complex. But when you actually start looking at how you can do flexible tag rewrite, it brings you to MPLS. If you actually start looking at how you can do VLAN interfacing and rewrite tags, the vendors that support that flexibly wind up doing it as part of VLLs or VPLS implemented on top of MPLS. And that's what got us looking at this as a technology. So you can use MPLS transport rather than Ethernet switching to enable the logical interconnects. And we're not talking about here having the clients, the exchange clients, implement MPLS. They could or they could not. It appears as VLANs. All of the PNIs that you're enabling appear as VLANs to the customer. So same layer 2 presentation. We're talking about doing something that's a little bit further out into the exchange topology than what AMSIX presented, in that it actually goes down to the configurations of the customer port, but that's where it stops. So with MPLS, you've got an enormous namespace. You can have billions of virtual circuits, and it's unique on your platform. It's unique. That virtual circuit, the PNI, maps into that space. And then at the very edge, you assign a VLAN, which is unique on that port, associated with the point-to-point or multi-point circuit that you're creating. The VLAN ID is only at the edge. It's no longer part of the frame or packet in MPLS. It's just used at the handoff. And the VLAN IDs then become something that people can bilaterally negotiate or, set. One of the very interesting things when we looked at a deployment of this is that in some cases you'd think this flexibility would be very useful, the ability to have party A and party B have different VLANs. But when you're actually doing this for peering, there are a number of people that said, it could get very confusing knock-wise if we have different VLAN IDs on this exchange, on this PNI. So you may still have some of the complexity of having to negotiate between the parties which VLANs are used or not used, but you have flexibility. You can use different VLAN IDs if you want to solve the conflict. And one of the really big things, and we see this from the AMSIX move, is taking running of the exchange from layer 2 into layer 3 gives you tremendous flexibility with both traffic engineering and scaling and also debugging. The tools are just much more flexible to do looking at the infrastructure at layer 3 than layer 2. And the protocols give you much more functionality. And now instead of having blocked ports, you can run in parallel. That also gives you operational advantages because if you've ever run a very large network, you know that you can have ports that are up that you're not running traffic over, and then all of a sudden you run traffic over them and you get you get link errors that you never see unless you're actually running traffic. So the ability to take a large infrastructure and have layer 3 traffic engineering to interconnect between the edges gives you scalability as well as operational advantage. Security. If you implement an architecture that gives you the ability for people to have point-to-point connectivity, then every virtual circuit's isolated. You don't have broadcast storms unless the people involved are engaged in the bugs or malfeasance. There are two different ways looking at the Brocade and the Juniper, the two platforms that we're familiar and we've done this with, that you can actually implement these PNIs. One is you can use VPLS, which can be point-to-point or multi-point. With VPLS, you still have CAM tables, and there's still a little bit more work going on, say, at the core of the exchange. With VLLs, you can't do multi-point. It doesn't let you do the shared broadcast domain, but Now you're just taking something as a magic magic frame transport, and you actually simplify. If you have somebody who's got 200,000 MAC addresses, your exchange point can actually be, completely orthogonal to that. Doesn't even notice. If you've got point-to-point, no one can be injecting. It's really just between the two parties. You can run IP, you can run anything else that you want, and you could run layer 2 transport. There's nothing, but no one else's frames are going to make it in there. Another big advantage is accounting. If I present something to you as a VLAN, all of a sudden you can graph it. If you're running IP on top of it on the common platforms, you can definitely graph it. If you're not running IP, some more issues, but fundamentally that's how people engineer networks, is to have different kinds of traffic on different interfaces, sub-interfaces, VLANs, and most platforms can graph that. So now you can actually bill for it, which opens up more multi-purpose use cases for your device connected to that exchange, potentially dealing with customers selling or consuming transport, which a lot of people need, especially at the smaller exchanges. Also, it takes the exchange operator out of the middle of that and gives you some simplicity. You have more complexity in the provisioning of an exchange that's doing PNIs, or logical PNIs, but you as an intermediary for the billing data traffic flow is a little bit less. And of course, you can integrate this data. If you're able to pull your own devices, then it's already integrated with your own system. So a lot of different services that one can now offer, the main thing being you can do multi-purpose. You can peer, you can consume transit, you can sell transit, you can consume transport, you can sell transport, all multi-use on that port. Now there are some networks that will never, ever, 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 ever do anything but one kind of service on a port, but there are a lot of networks that would be open to something like that, especially if the platform supports segmenting that, supporting billing, supporting security, supporting accounting. And you can do that point-to-point, multi-point. You have a lot of flexibility. Another nice thing, jumbo frame negotiation can be, you can enable it at the back end, and then MTU can be configured between the different providers. So it gives you the chance. I don't think we're ever going to see jumbo across the whole internet. Hopefully we will, but it will happen eventually. But before or after IPv6 will be an interesting question. But you get a lot more flexibility there. As part of your negotiation, you can say, which party is going to provide the IPs, exchange either side? What VLANs do you want? Do you care? And what MTU do you wish to support? Another nice thing is if you have a core exchange and you actually have people that want to participate or people that want to take advantage of that connectivity and buy transit or buy transport, you can actually, most of the MPLS implementations of VLLs and VPLS let you do double tag popping. So you can actually hand someone a port, do Q&Q, and talk to a metro provider, and all of their customers can become customers of the exchange. Now, it's a policy question whether you'd ever want to peer with someone or sell to someone that's implemented like that, but it does vastly open up the audience if you're in a New York or a Bay Area or an area where there are a lot of companies, probably more than providers, connected to those metro transport fabrics. So there's a little bit of simplicity in this model with billing, a little bit more complexity in terms of provisioning. Now, this has already been done by WorldCom with PeerMaker. You can build a system, but you need to have a portal. It needs to be robust, and you need to let people invite, accept, all ticketed and tracked, specify VLANs, frame size, IP addresses in IPv4 and IPv6, and so it's a little bit of complexity, but certainly tractable, certainly can be done. So summary, the current exchanges are working, and in fact we're seeing some of these kinds of technologies implemented at least at the core. I haven't heard of any others besides AMZIX, but it certainly makes sense given that people are already running these fabrics using probably 50% of the case, vendors that support this kind of technology. But there's a lot of engineering that needs to go into the fabric and the entire solution. And there's operational overhead, there's operational complexity, and there's, it's really suitable just for peering. Multi-service, multi-purpose isn't really something that can be supported at large scale in the current exchanges. But taking technology that's implemented in a lot of the common equipment that's out there. At least Brocade and Juniper have pretty good functionality in the things that look like switches, whether they're started life as routers or switches. They've sort of converged and can do both Ethernet and MPLS, and could give a lot of flexibility in addition to scalability to Exchange platforms. So, questions, comments, razzing? Richard can take the razzing.
Yes, please come to the mics. I see at least one willing victim.
Thank you for this presentation. Arjen Fijn from M6. First of all, the MTU issue. On our platform, that's per port, so it doesn't work that you, in the sense you described here, it might be different on another platform.
On your platform, it doesn't matter. On the layer 2 portion, you can set the jumbo frames as big as your platform can support, and it won't break anything. But where it breaks is when the layer 3 side is misconfigured, because you have to know this packet can't go through. I've got to send an ICMP need frag. That's going to trigger path MTU discovery. So from your side, you just configure the biggest thing you can support, and you're happy. And then the issue is negotiation with the
routers have to solve it.
Yep.
Yeah. That's also with a lot of the security problems you set for a shared platform. You can solve things on the routers. Yep. People can do that. But my comment is, we do PI. We, in a sense, as you said, it will provide a tag. And we have the servers, and it's hardly used. Well, the reason, in my opinion, that it's hardly used is what I see is that people don't want to change their router configuration to a tagged port. They think it's a hassle. So some people say, well, we provide this transit over this PI. Just tag your port. And in more than half of the cases, we see that people just don't want to do that. They are happy, apparently, with the Exchange as it is. So we don't see many of the requests of coming to watch this model, basically.
So, this has been available on a lot of platforms, Equinix, where I'm a customer, and I've considered it. And the reasons that I don't personally use the VLAN tags, number one, it's very limited in scale. There's only so many of these you can do. Number two, we get into VLAN ID negotiation. So I don't want to, spend time. And it's a lot of time if you actually try to work this out manually. Well, I can use VLANs this. Oh, that doesn't work. This clashes with this customer over here. Trying to find a compatible VLAN ID gets very dicey very quickly. There's slow provisioning. It takes weeks to turn this up, and weeks is not acceptable, or even days. I want my peer up now.
For us, the provisioning is not slow.
Well,
we provide it in a day.
Okay, but it needs to be in seconds, is my opinion. It needs to be the same level of provisioning that you get on a multi-point exchange. You configure it, it's there, it's up, it's passing traffic.
IRC leads to ADD. This is a well-known psychological phenomenon.
Yes, we want it done fast. And also there's, I don't know about AMP6, but there's fees associated with each one of these. And I think a model that didn't have fees per VLAN,
I don't think the fees are that much of a problem. I see just operational people saying, well, I need to configure a VLAN tag, I need to take out my peerings for that. I don't want to do this for this particular service.
Yeah. If it's a manual process that's very limited, that's slow to provision and costs you money, I don't want to do it either. Yeah. But if it's a platform that's built around this, that negotiates the interconnection IPs, that negotiates these things, and maybe gives me cut and paste output into my router, suddenly it becomes a lot better.
Okay, fair enough. If you already have a system where you have to do this, it might be different. The /30s and /31s, you say that has to be provided by the IX?
It could be anything. It could be either endpoint.
Yeah, either endpoint could provide it, but I think there's value in cutting that out of the picture. I mean, if you look at what it takes to turn up a PNI right now, that's kind of a pain. You send an email, who wants to provide it? Okay, I'll do it. Here it is. And then you don't maintain the other side's DNS information because you don't have it.
It means that there is a huge increase of IP space that we need.
I don't think it's that bad, especially if you support 31s. It's the same IP space. It's just it's no longer coming out of either party back and forth. It's now coming out of.
But you need a /31 per virtual circuit.
Yeah.
Well, so now we have a port with 300 peers with one IP address,
Yeah.
Then that port needs to have 300 IP addresses.
It's a small increase in IPs, but I mean, people do this
Well,
today
it's
with PNIs.
It's
For
a
your,
small
for your
increase.
V6 fabric, it won't matter that much.
On V6, it would be a good driver for V6, that's true. One of the security issues you had is like sniff traffic. How do you do that on a...
The point was fundamentally that the platform itself, you can send someone packets where you pretend to be someone else's IP and pollute their ARP and have them send traffic to you. And yes, if you're running a well-run exchange where this is locked down to a MAC address, you can work around these issues. But fundamentally, the platform itself is vulnerable to this, and there's a lot of poorly run exchange points out there where who knows what's going on.
Yeah, it's way more difficult to run an exchange point than people think, that I can agree. But considered just the trend I see is we have this boot server going on where everybody shares the thing, also has security issues. It's becoming immensely popular. It's so popular that it's now a really vital service for our exchange point. Because what you said is like, it's difficult to get many networks to an exchange. Well, we get them from far away, from Asia, from Eastern Europe. These people don't speak very good English, so they're happy to peer with root server and they exchange multiple gigabits of traffic with each other.
What percentage of the M6 traffic is influenced by the route servers? Do you have any?
Sorry, I can't. I don't know that out of my head.
Okay.
But I know that there are members with multiple 10 gig ports which go to 0 if the route server is gone. So it is in percentages.
I have multiple 10 gig ports with you, and I will never touch the route server. And I can think of many. I can think of many other members, so it's not 0. I can think of many other members who are in the same boat.
Mm-hmm. Well, of course, you can do this model together with the shared exchange.
And yeah, you could implement. You know, if there was an MLPA where everyone wanted to peer with everyone, you could implement that as one VPLS service, interconnect them all, use a route server. That's certainly possible.
Yeah. Another comment. You say, okay, we can go to 8,000. Okay, sorry, this is the last one. To like 8,000 sites and stuff, or 80 sites and 8,000 members. I don't think this will scale to that, but our membership basically forbid us to do that. We have to stay in Amsterdam. Once we had the sort of suggestion to go outside of Amsterdam, we certainly had a full member meeting with members actually participating in a meeting and saying we don't want you to do this because you're basically competing with our own business. We are the providers that give connections to others.
I would agree with that. What we were talking about is within a metro area. So, you consider a market like New York, which might have 4 or 5 large carrier hotels, and then has hundreds of other buildings that there's existing layer 2 networks that interconnect where, you might be in an office building down the street, you might be able to buy transit over this for multiple providers. You might be able to take 2 locations, deploy a router, use it as your transport. So it really opens up a wide variety of services that you can't do on a traditional exchange today. And I think
those services are services that members provide.
Right.
No, not
clearly that would be a new exchange point business model.
You're talking about long haul. We're talking about...
No, I'm talking on metro as well.
Yeah.
But yes, there are some members who provide that, but there's also a lot of members who sell transit, and they would like to be able to sell transit to more people in more places. And I think that probably outweighs their interest in this. If people really want a dedicated wave or whatever, this isn't really going to...
One of the things that when people expressed interest in this model, one of the things in cities like Amsterdam and New York, cities where people have done a lot of there's a lot of diversity because there aren't massive buildings that people have deployed into, is the challenge in actually doing the provisioning to either extend your backbone to all those locations or reach out and reach customers. And so I think what Richard's saying is people have said, if you can solve this problem for us, we don't really care that you're competing with Metro Transport because fundamentally we're a consumer of Metro Transport for getting to our customers, provisioning our backbone or provisioning those access loops.
Okay.
Yeah, thank you. I think if there are no more brickbats or lightning bolts from the audience, Yes, you can flame them at lunch. We are returning at 2:30. So you're on your own for the next hour and 20 minutes. Thank you. Vote, please. Please fill out the survey. Please vote for the steering committee members. Go to nanog.org and fulfill your basic responsibilities for attending this meeting. Otherwise, we'll hunt you down.